Well, hello everyone, and welcome to the Mr. Math experience. Today we are solving a system of equations, but this time is 3 by 3. It means that we have three equations and three variables. Okay, so let's start. So we have our system here. There's a set of equations. The first advice that I'm going to give you is to name your equations either A, B, C, or any letters, or I like to give numbers. So equation 1, equation 2, and equation 3. I think that is very useful the moment that we have to recall these equations. Now, what is the route? What is the process? Usually, and this is the common process that we will do, we have to select first two equations. Okay, then we have to select another two different set of equations, and then eliminate the same variable on both process. Um, we eliminate the variable and we will create two different equations now just with two variables, and then we will solve as normal. So I'm going to explain a little bit more of this process. So in my route, in my decision, I'm going to take equation 1 and equation 2. Okay, that's going to be my first process. The second process that I'm going to do is I'm going to take equation 1 again and equation 3. Okay, so like you can see, there's a pair and there's another pair. From both equations, I'm going from both of this sets of equations, I am going to eliminate the variable y. It needs to be the same variable. Okay, so let me write this down. So equation 1 says 4x plus 4y plus z equals to 24. And equation 2 is 2x minus 4y plus z equals to 0. On this case, the easy way how I can eliminate this, and I want to eliminate the variable y, is just by um, adding these two equations. The moment that I'm adding both equations, uh, 4y minus 4y, it's will cancel out. So I have here 6x plus 2z equals to 24. Just to make it easier and to simplify a little bit, let's divide this entire equation by 2, then every element of the equation, and we will have 3x plus z equals to 12. Okay, it is very important, this equation here, because this is the result that we have from this first process. Okay, so now we continue with equation 1 and equation 3. So equation 1 says 4x plus 4y plus z equals 24. That's equation 1. What is equation 3? Will be 5x minus 4y minus 5z equals to 12. Again, what is going to be the process here? Just add both equations. And it's happening the same. Look what happens here. 4y minus 4y, that will get cancel out. That will cancel out, right? So we have 9x, that's addition, um, plus c minus 5z is negative 4z equals to 36. On this case, I cannot simplify anything because there's not a common factor between 9, 4, and 36. So this will be my second equation as it is. Okay, so this is my second equation here, right? And then I have one in here and the other one in here. These two equations now needs to build a new system, and that is the entire idea. Now we're going to call 3x plus z equals to 12, and 9x minus 4z equals to 36. Okay, remember, we select a pair of equations, then another pair of equations. We eliminate the same variable. In this case, we select eliminating y from both of these sets of equations. Now that we have done this, we have a new system of equations with this result. From here, we know how to solve this. It's exactly um, the same. Like we know how to solve equations in system 2 by 2. Um, very simple. We can multiply the first equation times 4. Okay, what we will have? We'll have 12x plus 4z equals to 48. Equation 2 will remain as it is. 9x minus 4z equals to 36. And then I'm adding both. What happens with 4z minus 4z? Will cancel out. And 12x plus 9x, that should be 21x. 48 plus 36, 48 plus 6 is 54, plus 30 is 84. Let's divide by 21 on both sides. Okay. And we have x equals to 84 divided by 21. X is equals to 4. And this is our first answer in here. Okay, x equals to 4. With this x equals to 4, we can use any of these these equations in here in order to find the value of c. So I'm going to use this equation that says, I'm going to plug this into 3x plus c equals to 12. But now x is not anymore just x. This value of x will be replaced by 4. So we'll have 3 times 4 plus c equals to 12. And this is 12 plus z equals to 12. From here, we can subtract 12 on both sides. This is gone, and then we'll have z equals to 0. This is another answer. Okay. Good. We have x equals to 4, z equals to 0. With these two values, we need to go back to any of the initial equations. We can select the first, the second, the third one. It doesn't matter. Let's select the number 1. We'll see what's coming from that. So it's 4x plus 4y plus c. Let's select that one here. 4x plus 4y plus c equals to 24. So let's check. 4x plus 4y plus c equals to 24. Great. Now, we know that the value of x is, we will replace this value because that is 4, and we will replace the value of c, that is 0. Okay, so we'll have 4 times 4 plus 4y plus 0 equals to 24. Okay, from here we have 16 plus 4y. The 0 could just disappear from there, equals to 24. Let's subtract 16 from both sides. This is gone, and we'll have 4y equals to 8. Therefore, we have, let's divide this by 4 on both sides, and we have y equals to 2. And that should be our third answer. So if we want to write the solution for the system, right here, our solution, x, y, and z should be equals to x is 4, y is 2, and z is 0. Let's see how that works, how this solution works into our current equations. Okay, we have here 4, 2, and 0. So on the first one, this one here, 4 times 4 is 16. Y is 2 plus 8, that is 24, plus 0 equals to 24. So the first equation works great. What about for equation 2? X is 4. Let me put this up here so it'll be easier. Okay, good. So x is 4. So this will be 2 times 4. That'll be 8 minus 8. That is 0 plus 0 equals to 0. Perfect. It worked good. And for the last one, for equation number 3, 5 times 4 is 20. 20 minus 4 times 2 is 8. That'll be 12. Minus 5 times 0 is 12. Okay? So we just verified, it was a quick and easy verification that this solution actually worked for our system. All right. Um, take a look at the process. Thank you for watching. Remember that you can send your homework, you can send your exercises. We will be glad helping you and supporting you. Remember, you can go and visit gomrmath.com. We'll be glad helping you. Thank you.